Hello everyone, welcome back. If you're here for the first time, hello. We have hit 300 subscribers on this channel just a couple of days ago, and I want to take this opportunity to thank you all for coming here, watching these videos. I hope you learned something from these, and just wanted to say I really appreciate all of you folks coming out and watching the videos, even the bots. So, as you can see here, my wallpaper has changed. We're a couple of days or one day short of Christmas here in Germany, so I decided to just set up this ugly, very ugly Christmas wallpaper. This is sort of a premonition because it's only gonna get uglier from here. I'm going to tell you why in a second, but first the question is which malware are we going to analyze? Because we have just broken the subscriber record on this channel, what better malware to analyze than Record Breaker? Record Breaker is also known as Raccoon Stealer 2.0. It is the successor to Raccoon Stealer. So now, why is it getting ugly? It's getting ugly because we are gonna do some Ghidra scripting. Just had a sip of coffee there. Okay, so I have this sample which I'm going to analyze. It's pretty recent, the 19th of December. Today is the 23rd, so it was uploaded 4 days ago. This is, as you can see, a record breaker sample. I will post the hash in the description as per usual. And if we come down here, you can see that UnpackMe has actually unpacked. So this is the original. What was the hash? Just a second. This was the hash. So we're starting somewhere here, and stuff is getting unpacked. You can see that it's pretty much like the first stage, second stage, third, and fourth stage. So here I didn't bother with unpacking. I let UnpackMe do the work for me, and I just got the last stage, which is Record Breaker. I have just taken this, loaded it up into Ghidra, done the analysis, and here we are at the start. We're in the decompiler, and let's have a look at the functions real quick. So you can see that there's only an entry. You don't see a main, you don't see any function names. As for the imports, there's also not much going on here. So this malware is a stealer, and at some point it's probably gonna communicate with a C2, which means that at some point we should see some libraries being loaded here which just enable the communication to the internet, to some domain or whatever. So this is something we have to look out for. This load library, this get proc address, and kernel 32 DLL. So let's just go through this real quick. You can see that there's like this weird big string here, and so on and so forth. Here we have, for instance, spaces. So these are all spaces. And what I want to focus on today is one specific part of this malware. So if we go to get proc address and we right click and say show references to, you can see that this function is called many times. Let's just click on one of these, and here you can see the interesting part, and this is going to be the part where the APIs are going to be resolved. Now you can see that if you mark this function here, that this is called many times as well. And what we have here is probably the string decryption for the strings of the API, in the API that we want to resolve. So for instance, this first one could spew out something like write file A, and this would then be used down here to get the address of write file A to later call it. Okay, so we have this big list here, and if we look into this function, you just saw that Ghidra takes a moment to load all of this. Okay, so I originally wanted to go through this in the function graph, but I decided against it because it's just easier to show in a video what is happening here in the decompiler. But just as a reminder, the decompiler isn't always correct, so remember to actually look at the assembly. Alright, so in this function that we named mw decrypt string 0, we have these arguments. We have the data coming in, we have the string coming in, and we have this length coming in. Now, if we come down here, you can see the first interesting thing is actually this local alloc. This local alloc, here it just allocates the length that we get, plus 1 bytes. This 40 right here just says initialize the memory that is allocated to 0. And here we're just going to rename this to var mem. So about that, let's call it var allocated. And this is going to be the pointer to our allocated memory. This down here, as you can see, takes this allocated memory, adds the length to that, which we got as an argument, and it's going to set that to 0. And I put this little comment here. It says this sets mem, so the allocated memory at the position arg length to 0. So this is going to be the null byte for the resulting string, which we will get via the decryption. Now here we have a variable local 8 which is set to 0. All of this stuff is just junk, as you can see. None of this does anything. It's all junk. So what we have to do is we have to filter out the parts that we're actually interested in. Alright, so here we're having a check if length is not 0. So we want some length as an input. And then we start this loop which is full of junk again. The only interesting part is this part right here. And this is where the decryption happens. Now, as you can see, this local 8 is always added. So it's probably going to be, it's probably going to be our index. So we're just going to name this var I. And now we pretty much have to take care of this to do the decryption. There's one thing in here which is a little bit weird. So let's start at the string length. So first of all, we get the length of the string that was passed in. So we are going to call this var slen for var string length. And then we have in the next couple of lines the actual decryption, which just takes the allocated memory. Then it indexes it with I. And then it says, okay, set this allocated memory to this value here, which we get by the SOR operation. So the string here, which is passed in, is actually the SOR key. And it is also indexed by I, but it is always kept in bounds of its string length by the modulus operator. The weird part here that I want to showcase is this here. So you can see that first of all we have this var allocated plus var I, so we're indexing into the allocated memory, and then we have this indexing here again, which just says var data minus var allocated. So this here in the back, it looks pretty weird, but mostly when you see something like this, it is just indexing into arg data, like the argument that's in here. I looked at this in the assembly beforehand, and it is actually just that. So pretty much, if we would maybe, I don't know, write this down in pseudocode, let's just do, just call it decrypt.c. What this would be is we have var allocated is equal to, let's just do local alloc, and then we have a loop. So we have an integer here as the loop counter at 0. This integer is less than string length of data. And then we would have var allocated I is equal to data or arg data I sor, and then we have the arg sor key, and this is just going to be I modulus the string length of, just break this into a new line, arg sor key. That is pretty much the decryption routine that you can see here. I'm just going to rename this because I called it var, but it's actually an argument to this function. So as you can see, it's actually pretty simple stuff. This is something we've seen a lot in other videos, like minus the all of the junk code here maybe, but all in all, it's nothing really interesting. The problem here is, if we look at the cross references, this function is called a ton of times. So at this point, what we want is some sort of automation, just to make our lives easier. And to automate this, we're going to write a script. And the goal here is, as you can see, the data, which is to be decrypted, and the SOR key, they're located next to each other. The SOR key is always above the data which is to be decrypted. So what we're going to do is we're going to write ourselves a Ghidra script, and this Ghidra script is going to do the following. You mark this area, and then it is going to spit out the decrypted string. To do that, I'm just going to go ahead and open up the script manager here. That's just this little play button up here. And then I'm going to do create a new script. And here you can see we have Java. So we're going to select Java. And I'm going to put it in my scripts directory. And we're going to call this record breaker. Because we're breaking record breaker with it. Just a little joke on the side. And here you can see now we have the script. Now, this is, well, not optimal. I'm just gonna search for this, because in this editor we pretty much can't do anything. We have no code completion, nothing. So what you would usually do is you would get Eclipse. I am just going to launch this real quick. You have to download and set this up. I will put you a link in the description, which will help you. With this. So I'm just going to close all of these open scripts, and we have the home scripts here, and there should be something here. Here it is, record breaker. Okay. So when you start a script in Ghidra, you pretty much get the stub, and what we can do now is we can just add in our code which we want to run. So let's do that. First of all, we check if the current selection is not null. And if it's not null, for now, we're just going to do a print line, and we're going to say something is selected. Alright. Then let's open the sample again, and as you can see, we have something selected now. We're going to just press refresh, and then we're going to run. And here you see it says something is selected. So that's good. We have a selection. And of course, when we run these scripts, this particular script, we want to operate only on the data that we have selected. So let's remove this. And in the next step, what we're going to need to do is we're going to have to get the bytes here, like all of these bytes, so we can work with them. Now, to do that, what you can do with Ghidra is you can get bytes from memory, and you can get the addresses in the memory that you have selected from this current selection. So let's first get the memory. This is done via a memory class. So we type memory. I'm just going to call this mem. And then there is this variable current program. And from current program, we're just going to say get the memory. So this mem is going to contain pretty much the bytes in the memory of the current program. So the bytes that you see here. These are all going to be contained in this mem variable. But we only want the selected bytes. So what we're going to do is we're going to create an address object. And this is the start address, which I'm going to just call min address. And this is going to be current selection. And then we can just, sorry about that, don't know what's going on there. Just do dot, and then you can see it already gives us some suggestions. And what we want is get min address. So we get from the current selection the minimal address that has been selected, and we're going to do the same for the max address. And in the next step, we're going to print these just to see if we're, sorry about that, that was Rust syntax. We're just going to print these, so we're going to say min plus min adder. We can convert these to string. They have a toString method. I'm going to add this max plus, and then we are going to say max adder dot toString. Okay. So let's see if that works. We go back here. We just select all of this stuff. The min address is this with 90, starting with 94, and then it goes down to, or ending with 94, and the end address is this ending with B7, this address. So select the script. We're going to click on refresh here, so it loads the current state of our script, and then we're going to run. And as you can see, it's correct. It outputs the correct addresses. Okay, so let's remove this again. We have the min and the max address. So now what we want to do is we want to get all of the bytes in this area. So we want all of these bytes starting from this address going down to this address. To do that, we're going to use the memory. So here we're going to say first byte b is new byte. We're going to cast to an integer, and then we are going to take the max address, and from that we're going to subtract the min address. So what this line does is it's going to allocate a byte array, which is called b, and it is going to hold this many bytes. And in the next step, we will actually retrieve these bytes, and we can do that by using the memory that we have up here. So we just say mem dot get bytes, and then we pass in the min adder and b. So this just says start at the address min adder and then fill up the array. And the length is in there implicitly, so it's going to do that automatically for us. We don't have to set a length or something. Alright, so now on to the next problem. You can see here we have this data blob. It goes from here to here, so we have the XOR key mixed with the data, and we have to segregate those, and you can see all of these null bytes between them. So here are null bytes and here are null bytes. So we're going to use these null bytes to split the key from the data. This is probably easily achieved for a seasoned Java programmer. I'm not a seasoned Java programmer, so what we're going to do is we're going to write some really horrible code which will do this for us. So yeah, I'm sorry to all the Java devs for what is about to follow, but here we go. Function, and of course we're going to return the key in the end. So let's test this. We're just going to say byte key is equal to get key, and here we're going to pass a b. And then what we're going to do is we're going to do printf, or just say for loop, and it's key.len I++, and we're going to do printf. We can do characters here, and it's just going to be key I. Alright, so let's try this out. Let's mark this. Refresh the scripts, run. And we have an exception. So let's look at why we have an exception. Okay. Ah yeah, this is wrong. We have to take the key length, of course. Or we can just say len here, and then we should be fine. So now you also saw what an exception looks like. Just going to refresh, run again, and as you can see, we have successfully extracted the key string. Okay, now on to the next part. We have to get the data, which is also not a problem. We're just going to copy this, call it get data. So let's try that. I'm going to put this down here. Print as hex. Okay, so that's pretty much it. We're going to refresh and we're going to run. And as you can see, we pulled out all of the data bytes successfully, because the last byte is here, this 65, and then we have this 2f at the beginning. Okay, so let's just go through this real quick, what we have here. Well, first we get the key. To get the key, we just take all of the bytes in the area that we've selected. We go through all of the bytes until we reach a null byte. When we reach the null byte, that is the length of the key, which we save in len. Then we create the key byte array, which is going to hold the key, and we just shuffle the bytes over, return the key. The next thing that we need is the data. So the data is different because we have to skip over the key. So to do that, we just loop through the selected bytes until we reach a null byte. When we have reached a null byte, we're going to set a flag to 1. This indicates that now we have skipped the key, or we're beyond the key. And then we just wait until we find the first byte which is not null, and that is going to indicate the start of the data. Then we use a while loop again, just to get the length of the data and extract it like we did with getKey. And as you were able to see here in the output, this was actually successful, and we were able to get out the key here. That goes to here, and then this is just the data. It just looks this ugly because I didn't add a new line here, so let's just really quick add a new line here, and then select all of this stuff again. Refresh, run, and as you can see now we have successfully extracted the key and the data. Now all that we have to do is we have to implement the decryption function, which in my opinion is trivial. So what we're going to do is we're going to do void decrypt, and this is going to take the data, it's going to take the key, and then we are just going to loop through all of this. First of all, let's create a new byte array, which is going to restore the result. So I'm just going to call that, sorry about that, I'm just going to call that result, and it's as long as the data is. Then let's implement the decryption. This is just going to be a loop, and we are going to store the result of the XOR into the result byte array. So here we're going to cast to byte. We have data I, XOR key, I modulo key dot length. Sorry about that. The Vim plugin for Eclipse just doesn't work as I want it to work. So okay, we have pretty much the same decryption function that we have in the malware. Just keep the key bounded by this modulus operator with the key length. And now we pretty much have the decrypted bytes in the result. Now there's probably a way to do this in Java that is more elegant. I'm not a Java programmer, so I'm going to do it in the ugliest way possible. And that is just by taking the string s, casting the char, and then shoveling everything over. So now we can do print line. We say decrypted plus s. And that's it. We have now implemented the functions to get the key, to get the data, to do the decryption, and to show the result on the screen. So let's try our script. Let's mark this. Start from the bottom, come up here. And now we're going to go to the script manager. We're going to take record breaker, and now we are going to refresh and run. And as you can see, there's no output because we haven't actually called the function. So let's do decrypt. Then we're going to do data. Then we're going to do key. Come over here again, the script manager, refresh, run. And now you can see we have something decrypted, and that is load library W. So our script seems to work. Let's try another string. Let's take this down here. So this was load library W, and we have the same constellation here. So let's mark all of this, go over to our script manager, run, and now you can see we have get user default locale name. So our script is working, and we can now automatically, just by selecting the bytes and running the script, decrypt the encrypted API names in record breaker. Hence the name of the script, record breaker breaker. So I hope that with this little script, I'm of course going to upload this, you have just like a template, I guess, which you can use for your own analysis. I explained what the parts do, like these current selection, this current program, this get memory, just to give you an idea how you can script with Ghidra. I tried to make this as less Java as possible, so I didn't really use anything idiomatic to Java. Just tried to keep it as close to C as possible. So if you're not a Java programmer like me, it's easier to understand, I guess. At least that was my goal. If I wanted to make this prettier, what I would do is I would just go out and Google how to do that, like maybe how to convert a byte array to a string or something like that. But yeah, as I said, I wanted to keep it as close to C as possible, and I wanted to keep it, as you can clearly see by this line, keep it as close to the to what we can see in the decompiler as possible. Now that we're done, I just wanted to say thank you for watching. Have a nice Christmas if you do celebrate Christmas. If you do not celebrate Christmas, celebrate something else, go have some fun. Life is short, and I will see you around. Goodbye.